All right, well, we're winding down our study of systems, and right now we're just going to look at how do you make up your mind when to use which type, graphing, substitution, or elimination. So as you can see, with graphing, you have to have both of them equal to y. You can use your graphing calculator, find a point of intersection. Substitution, you have to have either x or y by itself in one of the equations and substitute in the value and then solve. And remember, you go back and you resubstitute. Then elimination, you're looking for opposite values of either x or y so that you can add them together and you will solve. Again, you will resubstitute one back into one of the equations. So let's look at graphing. Which ones would we do by graphing? Well, I can see right here the very first thing I'm going to do is I'm going to do number 1 by graphing. And so what I'll do, I'm bringing up my calculator, and here we go. No. Okay, I hit the wrong button last time. Alright, so now I've got my calculator up. So what I'm going to do is I'm going to put in my two equations into y equals. And I have 2x plus 1, and I have negative x plus 4. I'm going to graph those and make sure I can see my intersection. And I'm going to do second, trace, 5, enter, enter, enter. Let's try again. Second, trace, 5, enter, enter, enter. And it gives me a coordinate x of 1, y of 3. So now I can put that into my, actually I would like to see you graph this, but 1, 3, that works. So let's see, do we have any others that we have y by itself? Well, look, there's number 5. So let's go back up to number 5. I'm going to go in here, clear out what I've got, put in my first equation, 15 minus 2x, and then I have 12 plus x. Look at my graph. I cannot see my intersection, so I'm going to go to zoom. I'm going to find fit and hit enter. Now I can see my intersection. So I'm going to do second, trace, 5, enter, enter, enter. And it gives me 113. 113. Alright, on this page, that looks like all we can do to use our calculator. So let me go ahead and close this down. Stop this and close it out. I'm not going to save anything. So let's look for what we can use substitution. And we have to find one of the two variables already solved. Oh, look, number 3. So let's go ahead over here. Number 3, I know that y is the same thing as 4x. So I can come here, I can rewrite the second equation, 6x plus, and then instead of the y, I'm going to write what I have in parentheses, 4x equals 50, 10x equals 50, x equals 5. I'm going to plug this back into this one right here. So I have y equals 4 times 5. So y equals 20. My final answer then is 520. All right, do I have one of them solved? Actually, I'm looking at number 4, and it looks to me like I could easily make this a substitution if I would simply subtract 2y then I end up with x equals 12 minus 2y. And just looking at this, it looks like it would be much easier than trying to do elimination. So then I would rewrite this equation here, 4x plus 5, and we're going to put that whole 12 minus, oh, I'm sorry, I'm doing that the wrong way. X equals, so it would be 4 times 12 minus 2y plus 5y equals 24. So that's 48 minus 8y plus 5y equals 24. 48 minus 3y equals 24. Eliminate my constant. Make sure I bring down that negative. Divide by that coefficient. X equals 8. So I'm going to plug that back into this one here. And I'm going to get 8 plus 2y equals 12. Subtract my 8. 2y equals 4. Divide by 2. Y equals 2. So my answer is 8, 2. All right. I think we have done all the graphing and substitution. So now we're going to look for opposite values. Number 2 is a clear case of that. So I can simply add these together. 3x and 2x is 5x. These cancel out. Equals 30. We're going to divide by the coefficient. X equals 6. So I'm going to plug that into, let's do this one, 2 times 6 minus 2y equals 18. 12 minus 2y equals 18. Subtract my 12. I get negative 2. Remember, bring down that negative. Negative 2y equals 6. Divide by negative 2. I get y equals negative 3. So my answer is 6, negative 3. I'm going to box that in so it's easy to find. All right. Finally, we have number 6. Looks like the easiest way to do this is going to be to multiply this top one by negative 1. And I'm going to write that below here. That would give me negative 2x minus y equals negative 9. And then we're going to eliminate this one, add these together. It gives me x equals -2. Now I can plug that into one of these other equations. I'll plug it into here. -2. 3 times -2 plus y equals 7. -6 plus y equals 7. Add my 6. Y equals 13. My answer then is -2 and 13. All right, on to word problems. The perimeter of a rectangle is 90 centimeters. Well, I know I'm going to need P equals 2L plus 2W. The length of the rectangle is 4 times the width. So length, width, my first equation is length is 4 times the width. Know that the perimeter is 90 equals 2L plus 2W. I've got L equals something. It equals 4W. So I'm going to plug that in to this equation here. So I'm going to do 90 equals 2, and then I'm plugging in, instead of L, 4W plus 2W. So 90 equals 8W plus 2W. 90 equals 10W. Divide by our coefficient. And that means our width equals 9. So here is part of our answer. This, and I can plug that back into here. So my length equals 4 times 9. So my length equals 36. That's substitution. Oh, here's all those marks that I've been making and they've been disappearing. Now you know where they've gone. I have not figured out why it does that. It would be good to know. But, so here we are. We have adult tickets. A will equal the number of adults. C will equal the number of children. We have two totals. We have a total of 54 and 12. So let's set two equations. Equals 12 equals 54. Now this is just people. So the number of people plus the number of people equals that. Here we have money, 6 times the number of people plus 4 times the number of children equals 54. So money, money, money. All right. I think on this, really the easiest way to do this, two ways. You could solve for one, solve for A or solve for C, and then substitute, or you can find something. So I'm gonna use elimination here. So this is a 4C. I want this to end up, I want it to become a negative 4C. So in order to do that, I have to multiply this entire equation by negative 4. So I would come up with negative 4A minus 4C equals negative 48. All right, So now I can simply add these up and down. 2 adults equals, and 54 minus 8 is 6. So we're going to divide by 2, divide by 2. A equals 3. All right, so we know there were 3 adults. We can plug that back into this one. And we get 3 plus C equals 12. We're going to subtract the 3 from both sides. We know there were 9 children. So 9 children, 3 adults. All right. Oh, goodness. Here are some more of those marks. I'm not sure what causes that. I wish I could find it out because they get really annoying, and by the time we get to the end of our presentation here, I'm erasing. I would rather not have to do that. All right. The cost to rent a car from Rent-A-Wreck is $15 a day plus $30 deposit. So the cost equals 15 times the number of days plus 30. The cost to rent a car from Barely Running is $20 a day. How many days would you have to rent the car for the cost for both to be the same? Well, I think this calls for our calculator. No, not that calculator. We want our graphing calculator. All right, because we have essentially solved for y, both of them. So let me bring this down here. All right. So I'm going to go to my y equals. I'm going to put in this first one. 15 times our independent variable plus 30. And the second one is 20 times our independent variable, which is the number of days. I could graph. Oh, that's not looking good. So let's see. Zoom. Fit. There we go. I can see my intersection. Second trace. 5. Enter, enter, enter. So x is 6, y is 120. It's asking how many days. Our days are the independent variable, so x, our answer is 6 days. All right, last one. Let's erase some of those annoying little marks that we've got around here. You're going to have a birthday party. You plan to order pepperoni pizza that costs $8 each, and sausage pizza that costs $6 each. You need 100 pizzas and have $740 to spend. How many of each type of pizza can you buy? So, 100 pizzas. That's a lot of pizza. All right. So, if I say that P is the number of pepperoni pizzas and S is the number of sausage pieces, I could say that P plus S equals 100. Then our other total is 740, and I would do 8 times the number of pepperonis plus 6 times the number of sausage. I think in this one what I'm going to do is I'm going to solve for one of these, and I'm going to say that S, so I'm just going to subtract P. So I'm going to end up S equals 100 minus P. And then I'm going to substitute that into this equation where I have 8P plus 6. And then instead of writing S, I'm writing what S is equal to. 100 minus P equals 740. So that gives me 8P plus 600, that's 6 times 100, minus 6P equals 740. Combine my P's, I have 2P plus 600 equals 740. Subtract my 600. You see lots of steps here. Lots of steps. 2P equals 140. Divide by 2, divide by 2. P equals 70. So, I have 70 pepperonis. So, 70 pepperoni pizzas. So I can plug this back into this one. 70 plus S equals 100. Subtract the 70. Sausage pizzas equals 30. So I have 30 sausage pizzas. Could I have solved that with elimination? Yes. But substitution seemed like it would work very well. And that is a lot of pizza. Take care. See you for our last one next time.